integrate this? Or what's it asking you to do?
Just split it.
Just separate it out. So what are you trying to separate it out into? A over S plus BS plus C over S squared plus 3S plus 2. Now why is it like that? Like this? But it's easier to do what first? What's it easier to do first? Factor. So you have 2 times 1 plus S over S times what? S plus 2 times S plus 1. So what are you trying to split this into? A over S plus B over S plus 2. Hold on one sec, everybody. Yeah, so you were asking, can we simplify something first? We absolutely could simplify something first. Absolutely. You're absolutely right. That's great. So what's on the top and the bottom? Those are gone, right? So you literally could A over and B over A over S and plus B over S plus 2. Saturday morning, everybody. Okay. Is that where you got to, Josh? So now what did you do? You set this equal to?
I just multiplied by S times S plus 2.
So this is what we're trying to solve? So yeah, you multiplied both, and what'd you end up with? A times S plus 2 plus B times S is equal to what? 2. So what'd you do first here? S is equal. Yeah, so you could do this here. So you know, so S being negative 2 is one of those nice quote magic values. So if you do that, you end up with negative 2B is equal to 2. So what does B equal? Negative 1. Is that correct? And then S, what's the other nice value you could plug in? S being 0. If you plug in S as 0, you get 2A is equal to 2. So A is equal to 1. So you have your two values there. We want to substitute something in there. We want to substitute something, like if it was x squared plus 1, we'd be okay, right? Right? So can we, is there any way we could make it that? What could you do?
Can we pull 10 out of it?
Sure, so you could. So this is what I would normally do. You're right. You could pull 10 out, right? So what would you have? You have the integral 1 over the square root of 10 times what?
10, 1 over.
So it's plus 1 here, right? But it's x over what?
X over 2, actually.
What is it?
The square root of 10. Wait.
I'm just doing this to the 1/2 like this. Is that correct? Did I do that right?
No.
No, I didn't do that right?
No, I think that's right.
Did I? No, I'm not saying if this method is right, but is my math right there? If I pull out, if I pull this out and make it, I can make it a square root instead, if that makes people feel better. Is that correct? It's x squared, thank you. How am I doing? X squared over 10 plus 1. Is that good? Dx. Is that good? So then what could you do? You could do 1 over, so it's 1 over root 10 like this, right? And then you have, you're almost there, right? You have x over the square root of 10 squared plus 1 like this. Is that correct? That's right. And then what could you say? You could do, can you do use substitution? Like, yeah, what's our substitution going to be? What do you think? So x over root 10 is equal to what? Sine theta. Is that right? So here's the thing. These are all words that we want to have in here, theoretically, right? If we put sine in here, we end up with sine squared plus 1. We've mixed things together. Does that tell us anything? Does it tell us anything? Not really. It's really close. How about this instead? Let's try something out. Just pick a different letter. What letter do you want to use? U. Let's let U equal x over the square root of 10. Can we do that if we wanted to? As long as we keep track of it, it's okay. So we have 1 over the square root of 10, integral 1 over what? The square root of? U squared plus 1. And then what's the dx going to be? 10 du, I think. Root 10 du, is that correct? Right? Yeah. Dx is root 10 du, I think, right? So what cancels there? Okay, hold on, everybody. Stand up. Everybody, what is that?
That's like almost
you end up with the integral of 1 over the square root of, you square that, what do you end up with? 10 tangent squared theta plus what? 10. So what does that equal? 1 over the square root of 10. Let's just see if this comes out over 1 over the square root of what? Tangent squared plus what? 1. What is tangent squared theta plus 1? No, what is tangent squared plus 1 as a trig identity? What is tangent squared plus 1? So this is 1 over the square root of root 10. Yeah. Secant squared theta, right? And instead of dx, what does dx equal? The square root of 10 times what? What's the derivative of tangent? I know it's Saturday morning and you're secant squared theta d theta. So where's that going? Right over here. Square root of 10 secant squared theta d theta, like this. So what cancels? And then you end up with integral of 1 over secant, not secant squared anymore, right? It's just what? Secant theta times what? Secant squared theta d theta. So what do you end up with? Secant theta d theta. And then you'd have to integrate that. And it does come out to be the same thing, but this is why it cancels. So anyway, let's keep moving here to, what was it, 33, I think was the next one you wanted? Was that right, 33? Yeah. 33. If I could actually get this to pause, let's find out. So if you do this, so y is equal, if you're asking like, so we then, if we plugged it in right there, if you plug it in right there, yeah, so you can do more of it, but then you have the dy up there too. So then you have to turn it turns into secant, so things will collapse. But there's more to be done. X of t was 2t, and y of t was 2t. If I asked you to plot where does that particle go, how do you think you figure out where that particle goes? If you're totally lost, what can you always make? What can you always make? A table. So the t value, the x value, and the y value. So you pick some t values. Pick some nice ones. How about 0, 1, 2, and 3? What's x going to be? 0, 0, then what? And then 4, 4, and 6, 6. So if you plotted these points right here, what do you get? What is that line actually? 2x? Y is equal to 2x? Y is equal, these are the same, aren't they? So what's the equation? Y equals x. So this right here is one of the infinite number of ways you could write the equation y equals 2x. How could I write it differently? I could change it a little bit and it would be the same path. How about x is equal to what? Yeah. 3t, exactly. Thank you. How about y is equal to 3t? Is it the same path? Yes, but is the particle moving faster? Absolutely. It's moving faster in this case, but it's the same path. So how many different parametric equations can describe one path? An infinite number. As many as you want. It's the same as asking the question, how many different ways can you drive a car on the road outside? An infinite number. You can start, stop, like you can have particles, you will have questions where it'll be a particle just moving on a line, but you're gonna have a particle like moving back and forth, and you're gonna answer questions like, when does it turn around? When is it moving to the left? When is it moving to the right? You're going to answer questions like that. They are super, super common. Okay, so the particles can be, the parametric equations can be a little bit more entertaining. Describe the motion of the particle whose coordinates at time t are y, x equals cosine t, and y equals sine t. So could we use the same method we just used to graph this? We could. So let's try that here. So we have t, cosine t is the x value, and the y value, what was it, sine t? Sine t. Okay, so we have sine t right there. So let's just pick some values here. 0, what's cosine of 0? That was what, 1, 0, right? And then where is it?
A little bit, wait, it's 0.7.
It's what, root 2 over 2 comma root 2 over 2, right? Like that. And then where is it? 0, 1, right? So this was time what? 0. This was time pi over 4. And what was this one? Time what? Pi over 2. So if we did another one here, let's just do one more here. What would be another one? Pi over what? Just pi, right? We could just do pi if we wanted to, right? What's cosine of pi?
1, 0.
Isn't it negative 1?
Yeah, it's just
Cosine of pi is negative 1, right?
really.
真的 没关系 So it's to here. We skipped over here. So what's going on here? It's going like this. It's going like, oh, I made that a little too far. It's right here. So what is this actually doing here? What shape do you think this is? It's a circle. It is a circle. And where's it going to continue to go? It's going to continue to go around, right? So actually, it's the unit circle. So this is a particle moving in the unit circle.
Is that even cosine squared plus sine squared?
Exactly. So here's the thing. We can, it's called, we can turn a Cartesian function into a parametric equation. We can take a parametric equation and turn it into a Cartesian, right? So how would you know that this is actually the unit circle? Well, in this case, we can say that cosine t squared plus, oh, that's poor writing right there,
Cosine squared t.
plus sine squared t is going to be equal to 1, right? But what is that? That's x squared and y squared is equal to 1, which is a unit circle, right? So the point is, you can plot these if you have nothing else, and you can get a nice path here. Now, how many different ways can we write the unit circle? Well, we could change that to 3t or 4t or 5t, as long as I change this one as well. Question for you. What do you think happens if this is 3t and this was like 2t, if the t's weren't the same? Would it be a circle anymore? Yes, it would be an ellipse. Exactly, right. It starts bending. What these types of functions are necessary because not everything obeys, not everything wants to be a regular Cartesian function. It wants to be something that loops around. Okay, so let's keep going.